With a billion dreams riding on its back, Chandrayaan 3 is inching closer and closer to the moon. Just a few days from now, the Indian Space Research Organization will make a second attempt at attempting a soft landing on the moon. Now, this momentous occasion comes exactly 4 years since ISRO last went to the moon, but could not achieve a successful touchdown when the lander crash landed. Today, we have with us Professor Annapurni Subramaniam. She is the director of the Indian Institute of Astrophysics, Bengaluru. An esteemed astronomer, she has led years of research into star clusters, galaxies, and stellar evolution. Thank you so much for joining us, ma'am.
Thank you for having me on the show.
Yes. To begin with, I would like to ask you that a successful touchdown on the moon will definitely guarantee India a spot into the elite club of spacefaring nations, the US, Russia, and China. But as an astronomer, what is the scientific importance of this mission?
Yeah, so you would know that we are going back to the moon after so many years, like 50 years, more than 50 years. Now, the renowned interest in the recent years is mainly due to the discovery of hydroxyl or water molecules on the moon. But that is the one of the aims, one of the discoveries only. But recent discoveries have told us that there are minerals out there and which could also be used. So it's very important for us to know what is out there. And from an astronomer, we always have been trying to understand the formation and evolution of the solar system and how the sun is formed, how the planets are formed, and how the solar system is the way it is right now. And you can see that the planets, though there are many planets, they are kind of different, right? The inner planets are rocky, the outer planets are gaseous, and some planets have moons, some planets do not have moons. And what is actually the guiding everything in the formation and their evolution? And all the more so we need to know now, because we know that several stars out there have similar solar system. If we want to know more about what is out there.
Definitely. So a successful touchdown, it's basically a technology demonstration. So how will that help us in basically advancing our interstellar research and space exploration?
Yeah, so even to study a solar system, so far what we have been doing is by collecting getting the data from various missions. That is pictures and how you collect the electromagnetic spectrum. You could take it as pictures, you could take it as spectroscopy, like, different wavelength or polarization, things like that. So it's basically like, passive collecting data. You're not collected data actively by going there, collecting and bringing it and analyzing on the in the laboratory. So that is something normally physicists do, like, you have to chop it, do something, and figuring out what exactly the content is. So so far the interstellar molecular research or the planetary research all have been depending on this. But now we are seeing a kind of paradigm shift by getting the mining on the asteroids. Hayabusa missions have brought back material, and that material we are trying to analyze. So when the objects out there in the solar system are formed, they're formed differently. So the elemental abundances of the content varies from the center to the surface in each object. And what is out in the peripheral part of in Earth is not the same as in the other objects as such. So we need to understand that. Unless and until you sample it, it is difficult. So far, we have been taking pictures out there which are actually probes mapping various elements depending upon their property.
Right. So with this mission, it's India's third mission to the moon. We attempted our first mission in 2008, which made the discovery of water molecules. And then we went in 2019 to attempt a soft landing. And now we're returning there for the third time. Now, with this, it puts the focus back on interstellar research, on space exploration. Countries across the world have restarted their lunar programs. The US has announced the Artemis program. Russia is planning to set up a lunar base. Where does India stand in terms of space exploration so far?
So I think it's a very well-known fact that the Indian Space Research Organization has established itself extremely well with its capacity. And with this moon mission, with particularly the soft landing, will multifold its skill capability. The important thing is we should also know that every nation has its own way of reaching to the moon. So it's not a unified way. India does it in a very, very different way, very economical way, but it's one of the ways, right? And though it takes more time, there's no race on finding out who is reaching the moon first. But how you're going to move, how are you going to reach there and reach there perfectly? That's what matters, and that's what India has been doing. And this is the third time we are doing the same process, and we have mastered it. And the landing on the moon first happened as part of Chandrayaan-1 itself, because of this moon impact probe, which actually landed on the moon and the South Pole and gave us one of the clues for the hydroxyl molecules present there in the moon. And second one, of course, it crash landed, but the Chandrayaan-2 orbiter has been mapping the surface of the moon at extremely high resolution. So the huge amount of data is available from Chandrayaan-2, and Chandrayaan-2 orbiter will also play a major role for communicating to the land of Chandrayaan-3.
Right. Some of the images captured by the Chandrayaan-2 orbiter also helped ISRO in really determining the landing site for the third mission. Now,
Exactly.
right. So, ma'am, in terms of the space exploration, we have gone to Mars. We are now going to the moon. ISRO has lined up several other missions in the coming time as well. We'd also like to tell our viewers that ISRO has planned a mission to the sun as well, Aditya L1. And it's important to know that an important payload for this mission was developed by scientists from the Indian Institute of Astrophysics. Ma'am, could you tell us a little more about it? Because you're also gearing up for the launch of Aditya L1 in near future.
Yeah, so it's a very happy moment for astronomers, because the Indian space missions are now looking at the moon, and so AstroSat mission by ISRO actually has demonstrated that we can operate very complex missions in space. Now, Aditya L1 is a much more complex mission, because it's going to travel towards the sun. That's the L1 Lagrange point, is 1.5 million kilometers from Earth towards the sun. And it will have a halo orbit in a plane perpendicular to the line connecting the sun and the Earth. And now reaching there is the first time again for us. And once you reach there, you are actually kind of moving around a null point. Now, this is going to give us much more information on the sun. It is sun is, as you know, that's a star we are living with. And sun is also quite active in the sense that, there are magnetic fields there, and sun's activity have a periodicity of 11 years. And during the 11 years, the sunspots come and, they actually create a lot of this plasma ejections. And with our lot of electronic assets on the space, we need to protect them. And we also do not know if you have more interstellar missions, etc., coming up, then you need to know what is the particle density, what is the charge density, because electronics is the heart of the modules, which are the space modules which are out there, and they get damaged by these particles and charged particles which are out there. So we need to protect them, and many of them are it's controlled by the sun's activity. So we have to monitor the sun at close quarters, and science-wise, we need to understand, as a sun, how is sun performing? What is there in the sun, and how is its sun's energy, which is created in the center, is coming out? And we know that the corona is very hot, and why the corona is as hot as the center of the sun is still an unanswered question. And the magnetic fields we can measure to some extent, but how does the plasma come out and how the magnetic fields control or rather guide them, beyond that is still unanswered question. So one thing which we look forward to is predicting the solar burst, CMEs, and protecting the humanity as well as the assets out there. So that way it is important. The most important module, science instrument on this mission, that is the coronagraph. That would mean that coronagraph basically means that you actually look at the corona by blocking the disk. So that's a permanent solar eclipse created inside the instrument. So once you create the total solar eclipse, the disk light is blocked and you can actually see the corona. and you can see the study the corona. So that is the, it's a very complex instrument we have delivered, and we look forward to getting the scientific results from that particular instrument. And of course, the whole mission.
Right, right. So it's a very complex science to create instruments that can last in space and conduct those experiments. After the sun, ISRO also has a mission planned for Venus as well in the near future. Right. So I wanted to understand from you, whenever we are planning these interstellar missions, interplanetary missions, what are the complex challenges that we face? Why it is so difficult to create, to develop these payloads and even undertake a mission like Chandrayaan?
Yeah, so it is, first of all, the challenges regarding the rockets, where you need to lift the entire thing up to the space. So the more you travel, you need to have more fuel to push it beyond it, and also navigate it. So these are the challenges with respect to the mission. And out there, once you have sent it up, you need to have power. So power, electronics, control, communication. All these are challenges with respect to mission. But with respect to scientific instruments, you need to make sure that the science instruments perform there without any failure. It's not like an instrument you made on the tabletop and you try to test it. Something is not working, you can fix it. Again, you test it, it's not working, you can fix it. It's not possible. You have to have done everything possible on the ground, and more than that. Then you send it and make sure that it should work 100%. And if it shows something different, you should know why it is showing different. And also, the instrument goes through all this, shakes when the rocket is launched, and thermal cycles, and adverse conditions. And all these conditions, the instrument should perform. So the testing and the planning and even starting from the design is completely different for a space instrument compared to a ground instrument. So you have to plan properly, test it properly, and make sure that all adverse conditions are simulated. If you encounter multiple adverse conditions by multiple components, still it should perform.
Right.
So the testing takes a long time, because you need to make sure that all these tests are conducted. You can't do simultaneously. You have to do one by one, and then simultaneous. And then if any breakage, you have to plan again, design, redesign, put it, etc. So the time required for a space module or space instrument to be completed, it takes long. So you have to plan ahead, you have to test all this, and then only you can launch. So it's complex. Infrastructure requirement is complex, knowledge is complex, and time taken is more.
And India scores a big point, because in terms of that, our missions are very cost effective. Despite all the time that we take, the amount of resources and the money that is put into these projects compared to other nations is vastly less. Right. In case of Chandrayaan 3 as well, we have a lot of instruments on board. There are 4 payloads on the lander, 2 on rover once they successfully land on the moon. Let's talk about Chandrayaan 3. So why is it so difficult? What is that part of moon which makes it difficult for a spacecraft to land? And what are the complex signs that we hope to unravel once the mission successfully lands? Because the mission is going to be there for 14 Earth days, which equals to 1 lunar day.
Yeah, so there are many things which we take for granted, which are there on the Earth. One is the atmosphere. Second is the gravity. So when anything you throw up, it falls down. It feels the gravity. It also feels the air. So anything, the resistance is given by the air, and also the gravity pulls it down. So now we have so much used to the way we walk, way we breathe is due to these 2 factors. Now, when you take yourself out of Earth and put anywhere, these 2 are not going to be the same. And you have to simulate such conditions and make sure that things work. And if you want to land something on that, you have to deboost and slowly bring it down, right? That is the way it is. Now you are not approaching the moon in a straight way. You are actually going on circles. So you have to go there, then kind of position, and then you have to actually stabilize and then go down. And now you cannot assume that you're going to land on a tabletop. You're going to land on some very, very haphazard and non-uniform surface. So that's what I'm saying. The conditions are so very different. that you need to, if a couple of things go wrong, you have to make sure that still it works. So you have to make sure that the velocity is still moving. It is moving this way, it is moving this way. So the movement should be like this, and it has to land in such a way that it doesn't crash land. And also when it lands, it cannot tip or tilt because the bottom is not flat. And it's heavy, it's a small thing. So you do test and you do make sure that all these conditions are not, and also you're not going to tell them to, okay, now you see there is a rock out there, can you move a little bit so that you can avoid this? There's nothing guiding there, right? This is actually an automated thing. So you need to make in orbit, or it's an autonomous system where it has to make a decision whether to go down and there's an adverse thing. Is it possible? Assess the probability, and then say that, okay, I think I can land, go there and do it. So it has to perform such complex thing in an automated way.